before starting the video, if you can, please print out the PDF file on the description below so you can work with me. Let's find out how far is the distance from Mars to Earth. Okay, so let's say how far is Mars from Earth. So let's check it out. So the distance from Mars to Earth is 225 million kilometers. So we know that the distance from Mars to Earth is 225 million kilometers. So to write in numbers, this is 225 million kilometers. So this can be written as 2.25 times 10 to the power of 8 kilometers. So this is scientific notations, or we can call this as standard notation if you like. So for our scientific notation or standard notation if you like, so they will be written as a number times 10 to the power of n. So n can be any integer. For example, it can be -2 or can be -10, can be 5, 6 or 1 or 2 and so on. Okay, so that's n. So this number here must be between 1 and 10. For example, 2.34 times 10 to the power 4 is equal to 0.234 times 10 to the power 5. But because of 2.34 is between 1 and 10, so that is scientific notation or standard notation if you like. Whereas 0.234, because of this is outside of 1, remember the condition is this number here must be between 1 and 10. So 0.234 is less than 1, so it's outside the definition. So therefore, it is not a scientific notation. Or otherwise, you can also think like this. So you have a number which is a non-zero digit, that is 1 all the way to 9. So let's say like 1, 2, 3, and then up to 9. And you have a decimal point, and then the number behind, if you like. So this is, for example, 6.23. See, always this number must be a number that between 1 and 9 if you like, and then followed by decimal. So times 10 to any number. Another example. 45.7 times 10 to the power 3 is also equal to 4.57 times 10 to the power 4. So remember, so this is 45.7, so it's not a scientific notation. Remember, this must be between 1 and 10. So therefore, this is not a scientific notation. Because of second one, 4.75 is between 1 and 10. So therefore, it is a scientific notation. Or you can think like a number, point, some other numbers times 10 to the power 4. So this is scientific notation. Write the following numbers in scientific notation. So 2000. So 2000 is equal to, now if it's no decimal, it means right at the back here. So what we can do, we move 1, 2, 3. So 2.000, or I can just write 2. Okay? Times 10 to the 3, because I move the decimal 3 times to the left. 500,000. So again, no decimal, it means right at the back here. So we move 1, 2, 3, 4, 5. So 5.0 whatever. So I can just write 5 times 10 to the 5. So this is it. 38,000. So again, because it's no decimal, it means right at the back here. So we move 1, 2, 3, 4. So 3.8 times 10 to the power of 4. So part D, 3,045,000. So which is equal to, so no decimal again, right at the back. So we move 1, move 2, move 3, move 4, move 5, move 6. So 3.045 times 10 to the power of 6. 0.006. So now, because this decimal point here, we move to the right. So which is 1, 2, 3, 4, which is 6 times 10 to the 4. But because the decimal moved to the right, so that is minus index. Otherwise, just remember this, the number that less than 1, because 0.006 is less than 1, so we will have a negative index, if you like. F. So 0.00708. Again, this is less than 1, right? So the decimal point here, we move 1, 2, 3. So we stop there because we only need one number that before decimal. So 7.08 times 10 to the 1, 2, 3. But don't forget, because it's less than 1, so it's negative index. So minus 3. 0.00346. So which is equal to, again, we move the decimal to the right. So we got 1, 2, and we need one more because remember, we only want one digit before decimal. So which is 3.46 times 10 to the power of 3, which is negative because of less than 1. 0.6. So 0.6, so we only need to move 1, so that means 6. So times 10 to the minus 1. Please stop the video and try this one yourself. $230. So remember, there is no decimal. So what that means is it's right at the back here. So we move 1, 2. So 2.30 or 2.3, doesn't matter, times 10 to the power of 2 because we moved the decimal twice. And don't forget, because 230 is greater than 1, so this should be positive. Otherwise, just remember, you move to the left, the index is positive. Move to the right, then the index is negative. Now, to read this, we just break it into 3. So 1, 2, 3, and then 1, 2, 3. So that is 54,800,000. So which equal to, so the decimal is right at the back. So we move 1, 2, 3, 4, 5, 6, 7. So we stop there. So remember, always we need a non-zero digit in front of a decimal. So only 1, okay? So 5.48. So times 10 to the power of 7. 1, 2, 3, 4, 5, 6, 7. There you go. So 340,000. So which is equal to, we move 1, we move 2, 3, 4, 5. So 3.4 times 10 to the power of 5. This one here. So which equal to, so the decimal is right at the back. So we move 1, we move 2, we move 3, we move 4, 5, 6, 7. So 3.234 times 10 to the power of 7. 0.08. So which equal to, now this one, because it's less than 1, so the index should be negative, alright? So decimal point here, we move 1, we move 2, so which is 8 times 10 to the power of 2, but it's negative, okay? Part F. So we move 1, we move 2, and we stop there. Remember, only one non-zero digit in front of decimal. So which is 4.908 times 10 to the power of minus 2. G. So which equal to, we move 1, move 2, move 3, move 4. So 3.45 times 10 to the power of 4. But is negative. Last one. So to do this again, we just move 1, 2, 3 to the right. 4.576 times 10 to the power of 3, but it's negative. Thank you so much for watching.